We're good.
We're good?
We're good.
All right. Can we make this out further or no? All right. Welcome to our talk, Get in the Box. Too loud? This is going to be about containerizing red team infrastructure. So briefly, real quick, we're going to do a quick introduction. We'll talk about some common industry practices, specifically around red team infrastructure. We're going to talk about Red Swarm, which is a creation that we have kind of automating and building out the red team infrastructure. We'll talk about Terraform, Ansible, and Docker Swarm. We'll hit on traffic and routing, which is what we're using on the back end. We'll discuss monitoring when it comes to your infrastructure. And then we'll touch on a piece we're calling Sojourn and have some closing thoughts and any questions. Wow, fun. So I'm Dan Astor. I'm a principal scientist at Security Risk Advisors. My background is in pen testing and red teaming. I've been doing that for the past 10 years. I enjoy breaking things, and I do like metal, but I can't compete with Jonn.
And hi, my name is Jonn Callahan. I have only been doing red teaming for a couple years. I primarily come from an AppSec, cloud security, containerization security background. So I worked a lot with like engineering side of the house, more so than the offensive side of the house. So that kind of funded a lot of where my thought process is coming from on a lot of this. And yes, a big metalhead. You want to talk about it, we can come afterwards. I love metal. Can everybody hear us all right? We good? Okay, cool, thank you.
So just from a show of hands, how many folks in here do red teaming, deal with red team infrastructure at all? Okay, good.
4 people.
Awesome. So for the rest of you, just level setting some terminology that we'll kind of discuss throughout this. The first part's a C2 server. So a C2 server is something that's pretty crucial for red teams. It's what we use for command and control. That's what the C2 means. It's basically a system or a platform that allows you to either send or receive communication to some type of compromised endpoint. A C2 channel is the mechanism that's used to relay that information back and forth. So something, maybe it's going to call out over HTTP, HTTPS, WebSockets, DNS, you name it. It's the means for how it's communicating across the network. The next thing is an implant. This is something that we'll talk about too. An implant is the piece of code that gets executed on an endpoint to communicate over a C2 channel to our C2 server. And then the last thing, this isn't something that's typically well known, but a redirector. You never really want to have your infrastructure just sitting out on the internet. You never want to have a C2 server just exposed. There's tons of bots that just scan for that and then publicly shame you. You end up in some ban lists, things like that. So you always want to protect yourself. And one of the ways you can do this is through the use of a redirector. A redirector is basically, you could think of it as a reverse proxy that sits in front of your infrastructure, and it will do whatever you want, but you're never exposing your C2 server directly. You have some type of intermediary in between to filter and route the traffic. So when we look at red team infrastructure, this is a pretty well-known example deployment where you've got your target environment on the right-hand side here. This is going to be your compromised endpoints, the users that you're targeting. There's a lot of red team infrastructure that's kind of through the use of single-use systems, so they'll have multiple redirectors set up. They'll have multiple standalone, whether it's a phishing server, some type of C2 server, a web server, and so at the end of this, you may end up having somewhere between 10 or 15 standalone systems out there that's just being used as part of your infrastructure. Another example of this is where you'd have your C2 servers where you've got multiple redirectors in front of it. You want to have different domains, different providers that you're using for routing. So this is just another example of, but again, there's still a lot of standalone systems here where you can kind of count. There's a handful of just different systems that are being used where it's not necessarily efficient. Several years ago, kind of when Terraform started getting pretty hot, not as hot as on the DevOps side, but when it started getting hot with red teaming, a lot of people started going in on Terraform and using it as a means to deploy infrastructure rapidly. And then so they put together some type of Terraform plan that would spin up all of these different systems. Then they're going to use something like an Ansible to go through and actually configure the applications that are running on it, setting up something like Nginx for a redirector, or deploying Cobalt Strike and configuring that for your environment. So they'll kind of go through that, perform the engagement, and at the end of the engagement, run Terraform destroy to tear down the infrastructure. So this is kind of the previous deployment strategy that's been talked pretty widely about on the red team infrastructure side, but we can do better. And some of the issues that we have with this type of infrastructure deployment is because you're deploying a lot of single-use systems, there's a cost that's associated with each of those systems. And so if you're standing these up for a long period of time, several months for an engagement, there's a cost associated with that. You either bill it to the client or you accept it as part of your operating costs. You also have to deal with the maintenance that's associated with each of these servers. You've got individual servers that are out there. You have to deal with configuring, updating, maintaining, making sure that each individual system isn't exposed in some way. If you're going to work with Ansible, you have to go through and do a lot of OS level configurations. Whether or not you're having golden images being deployed as part of your Terraform deployment, you may have kind of long build times where that repeated configuration is applying on every single endpoint, which can add to time. There's some inflexibility when it comes to the architecture. You're kind of stuck with individual systems, how do you route them, things like that. And then you still have to deal with the certificate and domain management aspect of it. So whether you're using Ansible for that or some other automated strategy for configuring certificates and managing them, minting them, keeping them updated, they're all kind of things that you have to think about. When we're going to talk about here, there are some strategies that you can use and newer software that you can use to make this a lot easier. And none of this would be possible without calling out some notable work. When it comes to Red Team infrastructure, the original Red Team infrastructure wiki from Blue Team of Jeff was kind of the go-to standard for how to deploy stuff and how to structure everything. There's some pretty good posts about using Terraform for deployments along with Ansible. There was a pretty interesting project called Red Baron that came out for deploying all of your infrastructure using Terraform, which is a pretty interesting project. But not a lot on the container side. There is a project that came out recently called Warhorse that does use containers. However, it's still a lot of single-use systems where it's using Ansible to put a container on there, and so you're still spinning up a lot of instances building on the endpoint. And then the one thing that I will say, ByteBleeder had a pretty interesting wiki page, or a pretty interesting blog where it actually talked about using things like Docker Swarm, and it was kind of the first time that I had ever come across it, where he's kind of looking at some of the CIA strategies from the Vault 7 leaks and looking at how they deploy infrastructure and kind of showing how things can be done differently.
Cool. So with all that, that's the history of kind of how things have taken shape over the last 5 years or so in terms of popular red teaming methodology. So, oops, how did that happen? So with that, I kind of came through this again with more of an engineering background and working very much on the modern side of the fence of, containerization is everything, container orchestration is everything. So with that, I worked into, it's just a brief refresher for containers. Really the big takeaway from this here is that it allows you to run things in isolation. That means if you want to run multiple things on one server, you don't have to worry too much about them interfering with each other. And that is a huge boon when you're trying to deploy a bunch of things that might try to fight over, say, ports. If you want to run multiple things listening on port 443 on one server, it's a pain in the ass. Using containers, it's a lot easier, at least if you've got a load balancer in front of it or something like that. And so with that in mind, the way I was kind of thinking about this is, again, from an engineering perspective, where you're trying to separate your infrastructure from your services. So your infrastructure is your hardware layer, or more often than not, your virtual hardware layer. So your EC2 instances versus your bare metal boxes. It's things that very rarely change. You're not adding more servers, you're not removing them all that much. They're a fixed asset in a lot of way. Their configuration as well is very fixed. Once you stand up a server, you're not gonna really wanna change it. If you need to increase your disk size, you're gonna have a rough 30 minutes, hour trying to deal with that. It's just a pain. Services on the other side, your application layer, is far more flexible and it's constantly changing. So I'm constantly working on these application layer things. I'm making changes, I'm improving them, I'm fixing bugs. So I have a very, very rapid development cycle, and I don't want the hardware to get in the way of my application deployments. I don't want to have those things coupled together. So I want to keep them as decoupled as possible. And this is really where container orchestration comes in. So on the left side with our infrastructure, our goal is to deploy it with Terraform and then configure it with Ansible. Our Ansible stuff is very, very limited. Back in the day, about a year ago when I first started doing this, I was very, very hard about saying no Ansible. I want nothing to do with it. I hate it. I hate working with it. It's a pain in my ass. I've since seen the light, and there's a time and place for it. In this case, what we're using Ansible for is once we get our EC2 instances online, we're using it to configure our Docker Swarm. So that's what we're using for our containerization engine, container orchestration engine. And then on the right, we have our services. So the actual C2 frameworks, the phishing endpoints, the litany of things that we may have running inside our setup, packaged as Docker containers, and then deployed within our Docker Swarm. You'll see Docker Swarm and Docker Compose kind of used interchangeably throughout. If you're not very familiar, Docker Compose, the terminology is terrible. Docker Compose is the actual file itself, it's the manifest. It's also the name of the CLI tool you can use to stand up Docker Compose files locally. Docker Swarm is the actual cluster version of that, or it's the analog to Kubernetes, where you've got multiple nodes where you say, I want to run a service, you worry about where it runs, I just need it to run on this cluster. So you'll see me kind of using those interchangeably throughout. So this is already,
yeah, this is me.
See our note.
Okay. So the primary goal of going down this, I guess, research project that we initially took on, rabbit hole, of redoing our infrastructure, just because someone does it one way, and this has been the way that everyone does it, when you look at the public repos that are out there on how people stand up infrastructure, and how it's kind of taught in trainings and things like that, it doesn't mean it's the only way. And so the way that we wanted to make this is pretty straightforward. So all you have to do is just set up all of your variables, so whether it's your C2 domains you want to use, the usernames you want to create, the certificates that you want to have minted, the number of systems that you want to have deployed, or the number of Cloudflare or CloudFront instances we want to deploy. That all gets done ahead of time in a single variable file. So we have this TFVARs, which is a Terraform variable file. You just have to go in and set each of the fields to the different setting that you want. After that, all you have to do is run Terraform apply after you review your plan. That'll spin up all of the infrastructure for you, any of the services that we want spun up in AWS or Cloudflare, Azure, whatever you want. After that, it'll put together an inventory file for Ansible, and this will have the IP addresses within the different sections based on the role of that system. You run the Ansible playbook, it goes through, initializes the swarm, pretty much running this Docker stack deploy after it initializes the storm to get each of the instances up there. And then you can either run that Docker deploy command manually for each stack that you want to have deployed, or you can just use Ansible to deploy them all at once. So what this looks like, and it did not advance. Okay. So what this looks like in a traditional workflow, we go through, we run Terraform apply, it connects out to Cloudflare to configure the DNS records. It'll go through and stand up the EC2 instances that we want. It'll stand up any of that infrastructure that we need, and then it'll also go through and build out all of the configuration files. So we're having Terraform take all of that variable output that we didn't really know at the time, which was IP addresses, service names, DNS records, and it'll populate that into each of the Swarm configuration files, those Docker Compose files that Jonn was mentioning. So it'll automatically build all of that dynamically with the inventory that's created from Terraform. After that, the operator just has to run the Ansible playbook where it's going to go through, configure each of those nodes, set up Docker on them, initialize that swarm that we see there. It'll then take all of those swarm configs and deploy each of those services. So you really only have to run 2 commands, and then the operator just has to wait for the stack deploys to finish and then test the services to make sure everything's functional. So it's pretty straightforward when you kind of actually go in and running it. But there's a lot of stuff that happens on the back end because we're offloading a lot of that to Terraform, Ansible, and Docker Swarm. So that's kind of what it looks like all in one run. And then this is what the example deployment looks like. So in the past, we had all of those 10 different individual systems. Now we're just slimming that down to 3. We have a manager, we have 2 worker nodes, and all of the services running atop them. Load balanced, and then we just have all of the different redirectors. In this case, we're using a bunch of different services like Cloudflare, CloudFront, Fastly, and Azure CDN to push all the traffic through, route it, and then we can use something that we'll talk about here in a second called traffic to do a lot of the load balancing and redirecting and checking of the traffic. I think this is me still?
It's not persistent.
It doesn't look like the notes persisted.
Dan to cover.
Okay, cool. So then when we look at the Docker images, we kind of have them broken up into a couple different categories. The first one is a private container registry that we have, and these are for kind of internally maintained containers. So these are going to be things like your C2 server. We're not obviously going to just push that out to Docker Hub. Other things, whether it's specific logging infrastructure that we want to have for containers, and we have these wired up to ECR, and then everything's built on a pipeline, so we have fresh container images that are stored there and available for us to pull their version pins so we know what versions we're running. But all of this is housed in-house that we can just kind of run. And then there's the other services that are going to be things like meta services, so things like traffic or Portainer, which we'll talk about. These are things that they're public. They're maintained by trusted third-party providers, so the folks that manage and create traffic, they also build and deploy their own Docker images to Docker Hub. So we have those version pinned. We kind of review those to make sure that that version, nothing's changed that's going to break. But those we're fine pulling down externally. You could also just build them yourself and if you needed, host those within ECR as well. But for those, we're fine just grabbing those from the public repos.
How many red teamers does it take to get through PowerPoint? Ridiculous. So this is an example of a Docker file if you've never seen one before. This is basically the definition for a container image. So this particular example is for EvilGenX 2. 3 is out now, but this example came from before. All it does, clones the repo, runs the make script inside of it, configures the start shell script, and then that's about it. The start shell script itself just launches EvilGenX inside a screen session. The reason you have to do that is because EvilGenX was not designed to be containerized, and that's kind of like one of the pitfalls of working with this design is trying to take existing tools that were not meant to be run this way and shim them into a containerized environment. So sometimes you have to do some weird hacky stuff, but most of the time it's pretty clean. EvilGenX is one of those few exceptions where things get weird. But for the most part, the Docker files are relatively straightforward. So again, to come back to Docker Swarm, this is our container orchestration engine. And again, if that phrase doesn't mean anything to you, think Kubernetes, but not as complicated and complex. So its whole job is, again, to decouple the application from the underlying infrastructure. My application doesn't care where it's run. It only cares about what it needs. It needs half a vCPU and 500 megs of RAM. I don't care where I get it. Those are just the things I need. So using Docker Swarm, we can completely decouple those things. And again, I love Kubernetes. I hate it every time I see it in production. It's overkill for this kind of project. There's way too much complexity involved. And like Dan said a couple slides ago, the key here is we need easy turnkey use, both in deployment and modification. I don't want someone who wants to tinker with this setup to have to go and learn Kubernetes and everything involved with it. I love it personally. I'm not going to expect everyone else to go do that. Docker Swarm is much, much, much simpler. You can go read a compose file for the first time and you're going to understand what's happening. It's very much like Python in that way. If you understand English, you're going to understand what's happening. So the way Docker Swarm works is through what's called stacks. So a stack is a collection of services, and a service is a collection of containers. So basically what I'm doing is I create a stack for every single service, or every kind of service I have within the environment. So at the bottom here, you can see the example deploy command for Portainer. And I'll go over that, again, we'll go over that in a second as to what that actually is. But I've grouped everything necessary for the Portainer service into a single file. That includes the containers it needs to run. For Portainer, there's actually 2 sets of containers that need to run. All the networking configuration with it, any file system configuration, et cetera, et cetera. So all of that is bundled into a single file in one single spot. You run stack deploy, and you're done. That's it, easy peasy. There's really not much you need to do there. Looking at this again, we can see the heart of the swarm here. So on the left, we actually have our swarm infrastructure. So if you take a look at the numbers on the right, match up with the numbers on the left. So for example, number 1 in the top right-hand corner, HTTPS protocol hitting the foo.bat domain and the PH route. This first hits our redirector, which in a lot of cases is just CloudFront. CloudFront has a rule to say any traffic you get, push it back to our Red Swarm infrastructure. Sitting in front of that is traffic. Traffic says, hey, I got a request for HTTPS protocol on the foo.bat path, or domain with the PH path. I know I have an internal rule that says anything that matches those rules, route it to the phishing server. So using those kind of rule-based things, I can map external requests and domains to my internal services. And this all happens programmatically. Again, using Terraform to define a lot of this, just defining a bunch of variables up front, it generates all this for you. There's a bit of legwork up front, like making the templates, but otherwise it's all programmatic. All I say is, hey, I have a phishing domain here. This is my phishing service. Any domains or any requests for this host domain, route it to my phishing service. 2, 3, and 4 are much the same. So we've got more stuff coming through the redirectors from our target environment, hitting our internal stack. And again, we use those redirectors to obfuscate the Red Swarm infrastructure itself. We never want to directly expose our infrastructure to our target environment. And then below that, we have the same thing for our operational stuff. So us as Red Team operators are using this exact same stack. So when I'm interacting with the Cobalt Strike multiplayer server, the Sliver server, I'm doing so by routing through traffic and hitting those domains. So we have domains set up for our internal stuff that we don't expose, foo.bar.com. All I do is connect to that. Traffic is smart enough to say, hey, anything hitting cobaltstrike.foo.bar.com, route it to the Cobalt Strike server. So it makes it very easy for us to, again, split up each component, keep them very isolated and decoupled, but they're still working together in a programmatic fashion. And this is the full slide. Okay, so Portainer. This is something I've mentioned a few times now. I'm throwing a lot at you guys, especially if this is not something you've ever worked with before, if you've never worked on a red team for what this infrastructure works like, or never worked with containerization and container orchestration. Portainer is something we picked to make a lot of this a lot easier. Again, I'm very comfortable working on the command line and working with just raw manifest files, because that's what I've done a lot of time doing. For someone walking this the first time, that can be very daunting. There's a lot to learn. Portainer makes this very easy. It basically registers a service with inside your cluster and gives you a nice web UI that displays everything that's running inside of it. And it's very fantastic for debugging specifically. So just as an example of what it looks like, this is my test cluster I had stood up. And again, to go back to one of those stacks I was talking about before, Portainer just gives you a nice list of all the stacks you have inside of your environment. So if I am having trouble with one of my particular stacks, I can just jump in here and start looking around to see what's going wrong. So for example, I've clicked on the traffic stack here, and we can see we've got 2 services running. Each of those services has 1 container. At the very bottom, you guys probably can't see this because it's the very bottom of the screen, but at the very bottom, I've selected one of the containers, and I have a couple of options for actually directly interacting with it. In this particular case, I just want to open up the logs, and again, the bottom of the screen, but you can see the log output from the container saying configuration loaded from flags. So me, if I want to deploy a new stack, a new set of services and containers, it makes it very easy for me to jump in and just look around to see what could be going wrong, take a look at log output. You can also drop into a shell very easily. You can do all this by just running the Docker CLI, like that's perfectly fine. But if you're rapidly jumping around, and especially when I'm working on some of the more complex setups, like I'll get into at the end of this for our service called Sojourn, I might be looking at logs from 3 or 4 different things at the same time, trying to figure out where the breakdown might be, especially when I'm like proof of concepting something very new, and I haven't really ironed out the kinks yet. So Portainer makes it very, very easy for you to just jump in and get a high-level view of what's going on within your cluster. Oh, I'm covering this too. Cool. I love this slide. So traffic, again, another thing we've talked about a lot of. Traffic is a load balancer. At the end of the day, that's all it does. Traffic can be run in a wide variety of configurations. It just so happens to also support Docker Swarm and supports it pretty well from my perspective. So in this particular case, we use traffic as our ingress, and that routes to your C2 traffic, your phishing traffic, and all your canary traffic too, or whatever you may have. So it's primarily an HTTP proxy. So I'm going to say that up front. If you have like very weird or non-standard or complex TCP and UDP requirements, you might end up bumping your head against traffic, but it works well enough. The way it works ultimately is you configure a set of services and a set of routes, and you map rules to those to control traffic that comes in to services on the back end. Within Docker specifically, you do that via container labels, and you'll see that on the next slide. So the nice thing about traffic, and this works in other environments, not just Docker Swarm, but it's actually smart enough to monitor the Docker socket, so it'll watch your cluster for any container that comes online, and if it matches a rule, it'll automatically start getting served stuff. So I don't have to, once I deploy traffic, I never have to touch it again. It just sits there, monitors containers as they come online and go offline, and will dynamically set up all the routes between traffic itself and everything else. So if I've got traffic listening on worker node 1, and I've got service listening on worker node 2, I can hit worker node 1 and traffic is smart enough to say, hey, this is over on node 2, let me route it over there. So it makes it very flexible. Again, I don't have to care about my infrastructure anymore. I let traffic handle that for me. I completely decouple those things. All I know is that I've got a service running, and I can hit it if I match rules X, Y, and Z. The other really nice thing about it is it automatically renews Let's Encrypt certificates. So as long as you've got 80 and 443, or 80 open to the world, it can do its HTTP challenge, and you've got certificates ready to go. Nice and easy. And it'll automatically renew them as well. So it's very easy from that perspective. So this is a daunting slide, and we'll kind of jump into it, but this is what the labels look like within a Docker Compose file for configuring an externally facing service. So first up at the very top, we've got the enable and the constraint labels. So traffic enable just says, hey, I want traffic to actively monitor this service here. The second line says, sets a restriction. So within Docker Swarm, you can create virtual networks, and you can give them a name. So in this case, I created a virtual network called public. That way, the only way something gets exposed through traffic is if I explicitly put it on the public network. So it's just kind of a control against making any kind of mistakes or anything like that. If something's not on the public network, it can't get exposed. The second part here is I'm setting up the router. So the router is what sits in front. This is what consumes the traffic from the internet, or for external from the cluster, technically. So the very first line, .entry points, is I'm saying it's an HTTPS entry point, so I want you to listen on 443, and I expect you to honor TLS protocols. Same with the line below, it says explicitly enable TLS. The third and fourth highlighted line configures Let's Encrypt, so that cert resolver equals LE. LE is Let's Encrypt, which tells traffic I want you to create TLS certificates for this service, and I want you to use the Let's Encrypt service for it. And the entry point itself is a named port. So within my traffic configuration, which isn't shown here, but for configuring the traffic service itself, I have a named ingress called operator ingress TCP, and that's explicitly mapped to a port, which, what is it, Sliver? So for Sliver, I think that we have like 50,001 or something like that for our multiplayer server. And then above that, we have our routers themselves. So this is where the actual router rules come into play. So the very first line you'll see for the actual C2 traffic here. We have our rules set up to match against our domain, a path prefix, and a header. So kind of like SOP for us, when we expose our C2 services, we make sure we at least have some, beyond all the other controls you have in place, we make sure we have at least what we call a magic header in place, which is usually just authorization equals as a cookie, or not as a cookie, but as a HTTP header. And that's just one of the ways we use to prevent against scanning activity. So the way this is set up is if a request comes in and it doesn't match that host, that path prefix, and those headers, traffic is not going to route it back to Sliver. So that way we can know that the only things that are going to hit that Sliver container is legitimate HTTP traffic, or legitimate C2 traffic. The second one down below, underneath multiplayer connect, again, going back to where TCP and UDP gets a little wonky, your rules within traffic are very limited. In this case, you can only use the host SNI rule, and it has to be wildcard. So basically anything that comes in on TCP on the matching port, which you can see down here, 31337, that gets routed back to traffic. So really, because this is our operator endpoint though, we have this IP restricted. So we have it locked down to our VPN and that's it. So while we can't use the rules to really filter against bot scanning or anything like that, we just use traditional firewall IP restrictions, EC2 security groups. And then the top two, you can see the services themselves, that's the back end, that maps to the container itself. So Sliver is listening on port 443 and it's expecting TLS traffic. We don't, obviously once we're inside the cluster, we don't really need TLS, but that's what Sliver uses by default, and that's just how we've set it up in this particular case.
All right, one of my favorite topics, monitoring. So,
430.
Oh, yeah, we good?
Yeah.
Okay.
Just give me a time check.
Yeah. So when it comes to your infrastructure, it's good to have some type of monitoring in place. You want to know when things are going wrong. You want to know when things are going right. This can kind of break down into your traffic logs. So you want to know what HTTP traffic's coming through, especially if you need to debug things. Is the C2 traffic coming through? Is there something that's not matching? We have a means to kind of monitor that, because otherwise, I will say trying to debug using traffic without some type of monitoring in place is a complete pain in the ass. But then you also want to monitor your system health. Is my cluster, am I running out of disk space? Am I concerned about CPU utilization? Is one of my containers taking up way more CPU than it should be? Maybe I have some type of memory leak. So these are all things that we kind of want to know, and you can kind of put this into some type of monitoring setup. The other thing that we want to know too is we want to collect telemetry from the services themselves. So those containers, like John said, where we're getting logs out of the containers, we want to get things like the phishing logs. If someone successfully clicks a phish, enters their credentials, and we get a session token, or someone executes something, we want to be alerted to that, and so we want to have logs and monitoring in place. We also want to know what our operators are doing within the C2 platforms themselves. Maybe they're running commands they shouldn't be running. Maybe they're doing dangerous activities on an endpoint. Maybe someone needs to have a talking to. Yeah, so maybe someone's doing things they shouldn't. So we want to be able to kind of monitor what our folks are doing too, to make sure they're following procedures, and it's just good to have an activity log in case someone comes back and says, this server went down at this time, was it you? We can definitely say it wasn't. And then the last one is canary logs. And so canaries are, if you can think of kind of canaries and honey tokens and things like that, from a defensive side, we do the same thing offensively. So we'll set canaries within payloads themselves. So if a payload gets executed within a sandbox, we'll know. If someone does a lookup on a domain that we're not using, but we have that set as a domain, as a canary, so it's never going to hit anything unless someone's looking through that payload, pulling out the domains that it's reaching out to, and then they do lookups or they start interrogating the infrastructure. We'll get an alert saying someone is analyzing the payloads and looking at strings that are in it. So these are all things that we want to be able to know about, to tell us. When it comes to logging and getting the metrics, there's a couple different schools of thought, and we've got some real world examples of doing both. The first one is using something like Prometheus and Loki, where we're getting those metrics, and that's just native within the Docker Swarm setup itself. It's very lightweight. It integrates with the stack, like I said. It allows the setup to be very turnkey. And the log ingestion, because it's all within the swarm, it's all natively supported. The one downside with Prometheus and Loki is it's not as flexible, especially when we're working with that in some type of pipeline. So being able to get more bespoke logs from a C2 server or something like that, there may be some things that you need to do. The opposite side of the house is looking at something like a red team SIM, with which myself and Evan worked on in the past, or something like a red elk, where you're spinning up an entire SIM platform, in this case elk. You're going through and ingesting all those logs, you're formatting it, you're putting it into some type of structure that you can search on, create dashboards with. The problem with that, from our perspective, is it's very resource intensive. Elk, in a way, is pretty overkill for what we're looking for. There's a lot of functionality that you can use it for, but in our case, it's just very complex and very resource heavy for what we're looking to do. The plus side with something like Elk, though, is log parsing is like native to the platform because it's a SIM. It's one of the built-in functionalities, so it has a really strong, log parsing tool, Logstash.
So this is just an example of one of the Grafana dashboards we have. I have a couple here. These are just the out-of-the-box ones that are freely available to anyone. This particular one is Node Exporter. So one of the services we have stood up is called Node Exporter, and it's basically a container that's deployed globally across every node, and it just exports a bunch of metrics for the machine itself. So things like CPU utilization, RAM utilization, disk utilization, all that good stuff. Some of those things are pretty important to watch. Some C2 frameworks go a little hog wild on CPU, and things get weird when they start to peg all the way. So it's just a good thing to keep an eye on and set up alerts for as well. Another one for CAdvisor, which is very similar, except instead of working at the node level, it works at the container level. So now we have container level metrics where we can see what specific containers are using particular resources, in this case, CPU. And the final one here is we got one for traffic, so we can see all the traffic metrics that are coming in. We can see the actual real-time HTTP traffic. This one is particularly interesting because when we work red teams, a lot of times we'll talk to the client and be like, hey, we exfiltrated like a lot of data and you didn't see it, so we grabbed screenshots. A lot of the time we would use CloudFront. Grafana Dashboards is another great place where we can pull those metrics from. It's like, look, we just shoveled 12 gigabytes of data out of your network over the last 24 hours. Did anything fire? So stuff like that can be really interesting too. The thing to note with a lot of these dashboards is, again, these are just like out of the box. They have not been tuned. So there's a lot of work we need to do on the Grafana point, but they work pretty well. I don't know how many of you actually worked with both Kibana and Grafana. Kibana is so ugly. It's just like, you can tell it's 2 generations old. I think Grafana is really pretty, so we keep using it. And then this one, so the last 3 were for Prometheus, which we're not going to dig deep on this. Prometheus is a metrics engine, so it's a time series database. It collects statistics for a thing over a given period of time. So at this particular time span, these particular metrics were the thing. Loki is a log ingestion engine, so that's where you're actually consuming more traditional logs, things like access logs for like Apache or Nginx. In this particular case here, we're consuming traffic logs. So we can see access logs from traffic if we want to pull it from their direct actual file logs. In this particular case, I'm just doing a search on Acme. Like, for example, sometimes my Let's Encrypt stuff will break. It's my fault, I've broken something, but one of the things I'll do is I'll jump in here, do a search for Acme, and see if traffic is even registering an Acme request and trying to mint certificates, or if something else is going wrong. So it gives me, instead of me having to shell into the machine, jump onto the share, actually grep the logs themselves, I can just use Loki and call it a day. And as long as I've got a rule set up to ingest those logs, I'm good to go. Cool, so jumping into Sojourn. Sojourn is a stack I started working on over the weekend when I was very sad, because I build things when I'm sad. How many of you have heard of Nemesis, the new project from SpectreOps? Has anybody been following that? Just Evan, okay. So Nemesis is a really cool project. I philosophically love it. I really dislike the actual implementation itself. But SpectreOps has a ton of great blog posts about it, and they're really trying to do something very similar to what we're doing here. They're trying to bring offensive red team operations into the modern age, where you work with structured data, with automatic parsing, event queues, basically automating things. we're not looking to do the next DB autopone or crack map exec. We're not trying to automate the red team operator itself. We're trying to automate those boring administrative things that just eat up time and resources to try and let those operators do the things that they do best. Go reverse engineer some weird payload and build me a payload for it. Another big reason I brought this, or started working on this, is we went pretty hard into the Prometheus Loki stack for a while, and there are some limitations there. The alerting stuff specifically was kind of janky to do. So that DNS Canary stuff that Dan was talking about before, we implemented that in Prometheus, and the chain for doing that was just ugly. It was another case of things just being too complicated. These tools are built for like full enterprises running like Google scale infrastructure. We're not doing that. It's still great for us, and it's still lightweight enough to be used in these situations, but that particular feature was it was overkill. So instead, I went through and I built out what I'm calling Sojourn, which is a general purpose event looping framework. Again, my whole goal for this was to act as a force amplifier. I want to take the red teamers who are really good at red teaming and let them spend more time doing red teaming instead of doing the administrative stuff. So that can come down to like wrangling really large data sets. So something like you're going through and you're just browsing network shares or local file shares. I want to be able to ingest all that and put it somewhere that's searchable later on, so that in 2 weeks, and I'm like, oh hey, I saw a reference to that on some system somewhere and I need to go find it again, but there's no log of that because I was just manually CPing around. I can have that ingested in a back-end data store somewhere. Someone can quickly go search for it, like, oh, it was on this system in this path, easy, and go get it again. Again, setting up alerts becomes very important. Things like, say, new beacon activity. Someone executed our implant. I want to be able to have an immediate callback that says, hey, new beacon turned online, go look at it, go do whatever you need to do. Or even take the next step and do beacon automation. Like, great, new beacon just checked in, immediately kick off the keylogger, or immediately grab a screenshot, or start a hidden desktop session, or something like that. And then also like artifact monitoring, operator monitoring, like beacon logs themselves. There's a lot here I think we can do from an automation standpoint to really make people's lives easier, especially as someone who's leading red teams, and a lot of this administrative stuff falls on my back a lot of the time. Selfishly, I don't want to do it anymore, so I'm writing something to do it for me, like a good computer science nerd. So it comes down to a couple of core components here. Are you guys familiar with RabbitMQ? Yish, yeah, okay, all right. You got one hand, yeah. RabbitMQ is great. It's typically referred to a pub-sub system, publish, subscribe. It's an event queue system. So basically, I want to set up a queue within RabbitMQ. I want to be able to publish a message into RabbitMQ, and I want to have an arbitrary number of subscribers downstream of that consuming that message. So again, say I have a component that's watching my Cobalt Strike or my Sliver instance, and anytime a new beacon checks in, it's going to fire off a new beacon activity message. And then anything on the subscribing side of that can subscribe to that, and anytime that message gets published, the subscriber functionality is going to immediately trigger. And that may say, fire a Teams webhook to let people know that, hey, you have a new beacon, or kick off some automation to start the keylogger or something like that. The other data store component to this is a Postgres database. This is meant primarily for long-term data storage. So for example, if I have a component that tracks beacon logs, it's a general purpose activity tracker, so it's meant to consume beacon logs from a variety of C2s. A lot of C2s have export functionality natively built in, but what if I'm using multiple C2 frameworks? Now I've got to find some way to shim those together. The data isn't going to line up. I'm going to have to massage it in some way. It's a pain. So now I have one general purpose database table that stores all my activity. And then you can take it a step further and you can start tracking other things too, like phishing attempts. Like I can have some CLI tool that whenever I kick off a phishing campaign, it registers like, hey, operator A started a phishing campaign, targeted these users, used this payload, etc. And then I can export that with a click of a button, give it to a client and say, hey, this is everything I did. And it's no more that back and forth game of like, hey, did you do this? Or what timestamp were you in here? Or I know you launched a phishing campaign, but when did anybody click on it? I can just export it, call it a day. They have all the information they need. The third piece is it's a core Docker image, is what I'm calling it. RabbitMQ is great, Postgres are great. There are a lot of complexities involved with working with them. And again, I don't want to make people who want to help with this learn all those complexities. I want to abstract this away as much as possible. So on the RabbitMQ front, I export some convenience functionality for you if you're going to write your own module. If you want to subscribe to an event, all you do is say event.subscribe, feed it a name, and now you get everything you need. You don't have to worry about setting up the queues, setting up the exchanges, making sure the RabbitMQ server's online, what to do with dead letter queues, all of that like engineering nonsense that I personally love, but don't expect other people to have to deal with, gets abstracted away for you. And then the third one is AppSmith. The fourth one. I'm not necessarily tied to this. It's a low-code platform. There's a couple out there. I'm still trying to figure out which one I like the best. Really the core piece for this is to provide just a easy-to-use UI. So I have an application within AppSmith that will that wires into the Postgres database and displays all my payloads. So they're right there, or displays all my beacon activity logs. So I can download it programmatically, or I can just have a nice turnkey UI that's nice and searchable, like, oh, hey, I remember running this command, I don't remember the exact details of what I used, let me go search it really quick. There it is, there's all the flags I used, the exact configuration, et cetera. So just as a quick example use case, I have modules and I have messages. So in this case, I have the fsmon module, which is file system monitoring. And it publishes to the FS activity, file system activity message queue. So it monitors a directory and any subdirectories, and anytime it sees a change to a file within that directory, it fires event to the FS activity queue. It says, hey, a new file was created, or hey, a file was modified. On the other side of that, I have a payload tracker module, which subscribes to the FS activity queue. And its whole job, as its name implies, is to track payloads. So anytime it sees a modification to a file within the payload directory, it calculates the SHA-255 or 256 hash, dumps it into the database, and now I can view it directly within the AppSmith UI. So one of the things you do on a red team is you have to provide all the hashes of all the malware you just dropped on a network over the last 6 weeks, 8 weeks, 10 weeks. It's a long time and a lot to keep track of. It's very easy for things to fall through the cracks. Now I don't have to worry about it anymore. I throw all my payloads up to my file server. Hashes are automatically calculated for me. As long as operators are doing due diligence and not overwriting files where things get wonky, you're good to go. I don't have to think about it anymore. It's just done for me. How did that happen? Okay. Oh. All right. So a couple other, really, there's a million different things you can do this. Your imagination's the limit. You can do things, again, like beacon activity. I talked about that already. You can do an evil Gen X callback. So, hey, you've got an evil Gen X phishing campaign out. Someone actually fell for it. Now you've got their session. Great. Take my road recon module and immediately reach out and start scraping O365 to see what kind of configurations they have. Dump that data somewhere, and I can immediately go from a phishing campaign to having good insight into their environment. Yeah, there's a million different ideas I can come up with here, and it's kind of a new thing I'm working on, so really trying to flesh out all the use cases for it. Cool, so.
All right.
That was a lot.
Yeah, it was. All right, so like John said, we tried to implement this, and this is something we've implemented kind of over the past year and a half. And we presented this last year at another conference where we focused a lot just on Terraform. There were definitely some lessons learned from John's willingness to only use Terraform. But one of the big things was traffic definitely is best suited for HTTP. We did some work with trying to implement some UDP rules, a UDP service. It works, but like you said before, you kind of have to work with wildcards and things like that because there's not really rules supported at looking at the underlying packets themselves. The other thing too is when we're working with traffic, it's an overlay network, so it's on top, it's within the swarm itself. It's not kind of low level of the operating system where the rest of the networking is. So there's its own kind of pain you have to deal with there, especially with kind of sources and destinations and worrying about where things are within the swarm itself. That's just the way that overlay networks work. Also, Docker Swarm is a bit limited in the way that you have to use distributed volume. So we have a backend data store that we've got within like EFS or Elastic File System. And we have all of our data back there, but how do each of the containers mount that and have the data persist and things like that? They're all things that you kind of need to worry about. And you can't just easily distribute a volume to all of your containers through the swarm. The other thing is there's not an easy way at least we haven't determined it yet, where you can kind of control the container creation order. So when you're building out your stacks, the containers that need to be deployed for each of those, there's not necessarily a way that you can control the order it's going to happen in. So you either need to do that with Ansible and make sure that as you're deploying them, the containers will get stood up in the fashion that they need to, or you need to include some test cases to wait until the service is up before I continue spinning up the other ones. And then the last one here is just around infrastructure thoughts. So, like I said, I've been doing red teaming for the past 5 to 10 years, and just because someone does infrastructure one way doesn't mean that's the only way that you need to do it. There's kind of the sense in IT and even within security where if it's not broke, don't fix it. And a lot of things, carry over too, where it's, I don't want to change this because it works, but in our case, when Jonn came on a few years ago, it was, we were doing the exact thing where it was a lot of single-use systems, and Jonn was like, hey, there's these things called containers, and if you look at red team tooling and pen test tooling, there's really not a ton of support for Docker and containers. If you look at a lot of the tool sets that are out there, you either have to work them into a container. There's very few that actually have support with just containers. There's a Docker file associated with the tool itself. So I think in general, containers aren't that widely adopted in the offensive community. So it's definitely something to think about. But always when it comes to infrastructure, think of ways to reduce stress, improve your life when it comes to standing things up, reduce things that you don't have to worry about or the things that people are repeatedly doing wrong. Figure out ways to protect the infrastructure in the way that it should be. Explore new technologies and tools. In this case, it's Docker Swarm. Maybe next year it'll be something else that's hot. Who knows? And at the end of the day, be a hacker, think differently, try things out, come up with new proof of concepts, and just explore. And then I'll leave you here with some resources just around traffic, Docker Swarm, Loki. We'll have our slides published on our GitHub, but we'll get those up either tonight or tomorrow. And then if anyone has questions, we'll just hang out around for a little bit. Feel free to come up, but thank you for attending.